In the last video, we talked about what JDBC is and downloaded the MySQL's driver for Java called connectors/j. This is a jar file which contains all the packaged classes needed to connect and execute queries on a MySQL database. I've created a new project calling it MySQL Music with the usual main class and method in the dev LPA package. Before I do anything else, I need to include the code in that jar file in my project. So with the project panel open, I can select my project root, and from the menu, I'll select Open Module Settings, or F4 if you're on Windows. On the left pane of this dialog, I'll select Libraries. I'll click the plus sign at the top of the panel that says Nothing to Show. Here, you have two choices. You can get a Java library by selecting a jar file from an accessible drive, or if you've got Maven installed, you can download this from the Maven repository. I'll show you this first, then we'll remove it and add the jar we downloaded. To find this driver, I can type in com.mysql in the dialog there and pick the search icon to the right of that. This displays the different versions of the drivers available on Maven. You can just pick the latest version there. Here you can see it's giving me the information that the MySQL connector.j will be added to the MySQL Music module. So I'll hit OK there, and you can see that a couple of jars are now in the classes folder here. If you're already comfortable using Maven and modules, feel free to go with this. I'll be talking about Maven in an upcoming section. Now I'll remove this and simply add the jar. So I'll click on that module in the second pane, and I'll click the minus sign, and select OK to the prompt that asks if I want to remove that library. I'll pick the plus sign again, and this time I'll choose Java. This brings up the file dialog, so I'll go to the jar where I extracted it in the last video and select it. And now I've got my jar as a library. Selecting OK, I can close this window and we're now ready to connect to our music database. But even before we do that, I think I should talk a little about usernames and passwords. One thing you really never want to do is put this information in your source code. This leaves you with a few other options, such as putting it in a properties file or a configuration file or soliciting the data from the user. In a server environment, the connection and connection details would be configured as part of the data source, but we won't be testing in that kind of environment. So rather than encourage bad habits, for now, I think we'll prompt a user for the data. If we use a scanner with system.in to get the information from the console, we don't have a way to mask the password. That leaves us with console, which we learned early on in the course, doesn't work from the IDE. Since we haven't covered a lot of user interface options yet, except for a swing dialog, I'll just go with two swing prompts. I'll set these up in the main method. I'll create a local variable that will get populated by calling showInputDialog on a JOption pane. This takes a parent component which would normally be the parent page, for example. Here, I'll just pass null since we're using this outside of a true user interface application, and the prompt will say enter DB username. I'll use a different method on the JOption pane for the password. In this case, I'll first create a special type of variable. This is a swing class JPassword field that will mask the input. Instead of showInputDialog, I'll call showConfirmDialog, which is similar, but in this case, I can pass my password field instance as the second argument. The prompt will be enter DB password, and the user can choose OK or the cancel option in this case. I want my password to be an array of characters, which I'll explain in a minute, and I'll make that final. If the user entered OK, then I'll get the password from the PF variable, otherwise I'll set it to null. The getPassword method returns a character array and not a string. This is because a string might get returned, and this password, if it were a string, could inadvertently be stored on the string pool. A memory dump in any case could reveal the user's password. It's best practice to encrypt or hash the password, but I won't include that code here. In most cases, as I've said, this information will hopefully be securely stored on a server. I just wanted you to be aware of a few of these issues. Okay, so now it's time to actually make a connection. First, I'll set up a static string for what's called the connection URL. This is a string which uniquely describes how and what you're connecting to, and it's determined by the database vendor. I'll make this private final static a string called con_string, short for connection string. For MySQL, this will always start with JDBC : MySQL : followed by 2 slashes and hostname where we can reach the database. So localhost 3306. Next, we have another slash and then the database name, so music. Depending on what database vendor you're using, your connection string may be a little different. On this slide, I'm showing you a few of the more common databases and what a basic connection string might look like if the database was named music. You can see that some of the details after the JDBC vendor part may vary. Postgres and MySQL are similar, but Oracle, in this example, includes an @ sign before the host, and Microsoft SQL Server has a semicolon after its port, so be sure you understand the right connection string you need to use for your vendor. So we use the connection string as input to get a connection. As I mentioned in the previous video, there's 2 methods to do this. The first is with the driver manager class. Like opening a file, you want to open a connection in a try with resources block. Inside the try parentheses, I'll set up a connection variable, calling it simply connection, and calling a static method on the driver manager class named getConnection. This method takes the connection string and optionally the username and password. Here, I'll turn my character array into a string within the call to the method. If we get here, then we've successfully connected to the database, and I'll print that message. Another best practice, once you've used the password for whatever you need it for, you should reset the characters so the password is only in memory for the shortest time possible. Here, I'll set the password to all spaces. I'll catch any SQL exception that's thrown. If there's a problem, I'll rethrow a runtime exception. I don't have to close the connection because I've created it and implicitly opened it in this try with resources code. The connection will get automatically closed when this code completes. Okay, so let's run this. I'll enter dev user in the first prompt as you wanted to do if you followed along with the MySQL Workbench video. Next, I'll get prompted for the password. You want to enter your own password that you set up for this user in this field. Notice that I can't see the password because I used the swing J password field. My application will print success, connection made to the music database. So now we're successfully connecting to the MySQL database from a Java application using the driver manager class to do it. Before we do anything else, I'll show you how to connect using a data source. Before the try with resources statement, I'll add a couple of lines of code. The first statement will create a variable using type inference called data source, and I'll set that to a new MySQL data source, which is MySQL's implementation of this type. This constructor doesn't have any arguments. So I set the connection string by called setURL on that object. In this case, I've created a basic data source implementation. This will produce a standard connection object, much like I'd get with the driver manager, so it won't be pulled or used in a distributed transaction. If you're working in a multi-tiered production environment, your client will get a data source instance a different way. You'd use something called a JNDI naming service. I'll be talking about this service when I cover client-server applications a bit later in the course. When you get a data source through JNDI, you wouldn't need to specify the URL or the username and password. Let's now get a connection using this data source. First, I'll comment out the first part of the try with resources, so the first 2 lines. After this, I'll add a try with resources, but get the connection with the data source. This starts out the same as before, but this time I'll call getConnection on the data source variable. This code compiles, but if we run it, I get an error because I didn't pass the username or password that was supplied by the user to the data source getConnection method, so this fails. Again, if I had gotten the data source instance from the naming context or JNDI, I could use this getConnection method with no arguments. But since I'm using a basic data source, I don't have to pass the username and password I get from the Swing inputs, so I'll do that now. I'll pass the username and the password as a string. And rerunning this code, I've now got my success message. I could also have used the setUser and setPassword methods as I did with setURL. In fact, I can use data source without a connection string at all by using the set methods on this class. Let's do this. I'll comment out the setURL method. Now, I'll start typing datasource.set. Take a minute to scroll through the set methods available on this class. It wouldn't be an understatement to say there's a lot of options here. We'll just focus on the basics. I'll pick set server name from the list and pass that localhost. I'll next set port to 3306. Then I'll set the database name to music. I'll run this code and enter the user and password. And I get the same result. I'm not going to get into all the complexities of the data source type in this introduction to the subject. In this case, there's not much difference between these two methods since both connection types are basic connections, but data source is newer and generally preferred over driver manager. Data source should definitely be used in a multi-tiered environment that requires connection pooling or distributed transactions. Okay, so now that we can connect, it's time to do some of the fun work, which is getting data from the database, so let's move on to the next video.